Hi. Hello, everyone. My name's Shannon Appelkline, and I'm the lead technical writer for Blockchain Commons. Today, I'm going to be talking about Guardian Envelope's request and response system, both what it is and why it's important. This is kind of a little bit up on the stack from URs. So let's dive in. The request and response system is part of the expanded Guardian Envelope functionality that Blockchain Commons supports beyond the core specification that we've been working on. It allows one device to request something from another. Our implementation guide has more details, but here's a quick overview of everything. Requests begin as expressions, which are defined in BCR 2023-12, another of our research papers. They're functions with 0 or more paired parameters and arguments. Here's an expression that asks for a seed, and it includes a seed digest as its argument. Responses then begin as simple envelopes. The subject contains the result of a request, and a predicate contains an ISA that defines the subject. Other metadata can be included if desired, such as the name and descriptor for the requested seed in this example here. It's not quite everything. In order to turn that expression and its response into an actual Guardian request and response, you have to wrap them up. For the request, a new subject's created with an apparently random ID. Then the expression's encoded as a body predicate. Here's what that looks like if it's readable. A response works just the same. A new subject's created with the same apparently random ID as the request. Then the response is placed in a result predicate. There's, of course, more details to how all of that works. The request and response subjects that you saw are actually CBOR tags. The functions and the parameters that were in angle brackets are special known values for functions. Everything that you saw in a single quote, like function and parameter here, are known values too. The implementation guide, which is another BCR, shows how you can use all of this in an interoperable way. So that's basically what request and response is, but why would you use it? Obviously, they're an interoperable way to communicate, and that's pretty important in a balkanized digital asset world that seems to be growing more balkanized all the time. However, we think they're even more important for automating complex tasks, and that's where our use case comes in. Currently, non-automated systems have three major complexities, which are shown here. They require users to figure out how things work. We call those research points. To make decisions, which are decision points, and ultimately to push buttons, which are human actions. The more of these three complexities that exist, the less likely a user is to finish a task. So how does automation make that better? This use case that we've written on the creation of multisigs demonstrates the need for a request response system. Right now, we think multisigs are critical. As Christopher said earlier, we think they're the future of Bitcoin. They enable what we call smart custody without single points of failure or compromise. Even better, they're actually creatable today, which wasn't true when we started working on this 5 years ago. You can use Sparrow as a transaction coordinator. You can connect up a variety of signing devices, and you have a multisig, possibly a totally self-sovereign one where you control everything. We've written the scenario and we've asked people to try it, and we think the scenario is very clear, but there's just so much complexity in it that people stall out during it. And that's one of the problems that request and response helps resolve. The main problem with the current non-automated system for multi-sig creation is that you have to know a lot of stuff. You have to understand the lengthy procedure, and you have to have pretty good knowledge of how all of your devices and apps work. It's a really high bar, and that's not even counting all the button pushing that goes on. An automated multi-sig creation system built on request and response improves the situation by having the transaction coordinator, such as Sparrow, be a conductor for everything. It frees the user up from that task. It does the heavy lifting of managing the procedure, telling each device what to do, so that the user doesn't have to. It just makes requests, and the individual devices offer responses. The user does still remain involved. He has to ensure the safety of the system. They confirm whenever data is transferred from one device to another. Out of necessity, they take physical actions too, but it's a lot less that they're doing, and they have to know a lot less. So here I have two sequence diagrams that show the difference between non-automated multisig creation, which is on the left, and automated multisig creation, which is on the right, using request and response. Without automation, the user has to figure things out and do a lot of independent action. If you can actually see this sequence diagram, you can see there's lots of brains here, which talk about them having to figure out how things work. There's lots of faces, which show them having to actually take actions, a lot of actions. And there's some light bulbs, which are places they have to make a decision. In contrast, with the automated system, they still have agency, but it's through confirmations, which we can see as these thumbs up, rather than problem solving. Lots of automation instead of human actions. It's just a system that's going to be easier for anyone to use. And that's why we think request response is important. It reduces the need to research, to decide, and to act during a complex procedure without affecting the agency of the user. It guides the user instead and points them toward the important stuff. The ease of use turns an unmanageable task into a manageable one, maybe even a simple one. When I plotted out these two sequence diagrams, what struck me the most were the research points here, which again, were the places where the user really had to figure out how things worked. In the original system, there were 11 specific unique research points. And in the new one, there's just one, which is setting up the system to get going. But also the decisions are reduced and the human actions are reduced. And as I said earlier, we're pretty sure that's going to make people more likely to actually complete the task. Today, we're seeing the request and response ecosystem just beginning to grow. Foundation Devices is one of the earliest adopters because they're working on it for an upcoming project. And we think that's just the start, that there's a whole universe of automatable tasks that request and response could support, including functions like page join if desirable. For more, you should take a look at these two documents, which we created earlier in the year. The multi-sig use case for request and response is in our smart custody repo, which has a lot of documents on how to be safe in the usage of digital assets. And the implementation guide is in our research repo, where it's BCR 2024-004. That's it. Thank you. Any questions?
Thank you, Shannon. So one thing that we didn't discuss was, of course, these are all, all the request responses are envelopes, which means that you have the full capability of using any of the envelope features. So for instance, you can encrypt, you can elide various information. You can set it up such that the party in the middle cannot access the data that a party at the end of a series has access to. So we've not really fully explored all of the interesting choices that these scenarios might require. I mean, I've been kind of, struck that even with a trusted coordinator, Sparrow or something of that nature, it often ends up needing a lot more information than it actually needs to perform the transaction for you. So, are we even able to, you know, uh, you know, um, for instance, you don't necessarily need to know what the root key is. you know, um, so I think there's some interesting um, choices that can be made in the future. But the first step is just getting request response working, and then we can wrap in tofu and different kinds of elision and encryption protocols, for the different steps. Um, Wolf, what else would you say would you add to the?
I just add that, for anybody who's kind of coming, new to the whole conversation on envelopes, it's a very lightweight structure. You really only, have to pay for what you use in terms of, how big the structure is. It's, a Merkle-like tree, so you can actually transform certain parts of the structures. Chris was saying, like, elision or compression or encryption without uh, without paying a big penalty for it. And it's all kind of baked in. And very small structures are just there's very little overhead for them. So we designed it to be a very simple, very elegant structure that's usable for a wide range of tasks. And we're seeing how it fits into various kinds of use cases. And we're discovering that it really actually enables a lot more power in various use cases as we continue to experiment with them. Early in this presentation, you saw how we're looking at a general representation of graphs, and how then combining that with, for example, like holder-based elision enables various kinds of documents to be much more secure and much more protecting of and respecting of personal privacy and sovereign rights.
So right now, the low-hanging fruit on request response is for for coordination you have multisigs, as Shannon's use case demonstrates. The other one that we've been talking about and we're hoping to see this year is our first collaborative seed recovery tools, so that we can do what Ledger and other parties are doing with proprietary tools, but also with a limited set of sharing vendors. In our case, you could choose which recovery partners you wish to use, which not only could be, a major company with lots of protection, but could also be your own friends and colleagues, or could be offline in the form of an NFC card or even a paper document put into a vault. So we feel like there's some real opportunities in that low-hanging fruit for request response. The other area that this beside it, I mean, it's basically coordination and the collaborative recovery are the two. When we start talking about self-sovereign pay join, I think there are also some. I'm sorry, I'm getting some music from somewhere, and I'm not sure where it's coming from. Is it my computer or someone else's?
It's not over the Zoom.
Yeah, I hear nothing.
Okay, I see what happened. Siri started playing music for some reason. The I think I lost my train of thought. Uh, Oh, so PayJoin obviously is a two-party protocol. Right now, it can't be done offline. You can't have two devices, meeting at the next rebooting Web of Trust, and somebody wants to pay their share of the dinner, and has no net connection. Moving to sort of the more UR, QR, and envelope type structures would allow you to potentially do that completely through a QR mechanism. I think there's some interesting things there. But as soon as we get more parties involved, I mean, we've kind of seen with what's happened in the last week in regards to mixing services, any form of centrality of can be attacked in a variety of different ways. And we've seen evidence of that, with the recent news events. But there should be nothing that allows, say, the four of us who are all trying to pay for dinner at rebooting to be able to participate in a pay join together and mix all four of our payments so that none of us can be identified. So I'd like to see those kinds of futures. Any other questions or comments? Andrew, you've sort of stuck through the whole presentation. Do you have any questions for Dan or for us?
If not, I've got some questions about the
Sure.
meta, how you come up with these solutions. I've seen these slides a couple times when I've attended these meetings, the decision points, confirmation points, research points, human actions, automated actions. What do you call that framework? How did you come up with it? It seems like if you list all those out, you can figure out what actually needs to be optimized. It just seems like a great way to approach a problem.
Yeah, I don't think we have a name for it yet, and it really came out of looking at multisigs and saying, why is this so problematic? And so we thought, what are the different types of things that are happening? But maybe we should write it up as a problem-solving methodology or an analysis methodology.
It somewhat comes out of, my security design work and such. I mean, you can find a lot of its roots, back in the original Smart Custody book from 2019, I think. Where we talk about how do you think about adversaries, and then using that, we have some interesting metrics and approaches for how to use that to make decisions. And we've just then applied that to multisig and a variety of multisig scenarios, including, using various spreadsheets where, I mean, I think there was one spreadsheet we had that had like 64 different threats and of for on a multisig, where we could basically show that in every single case we had a solution for every single point of failure and single point of compromise, which are subtly different. Oftentimes they're the same, but but if you don't separate them, you'll miss some. So uh, uh, but yeah, that's we've done this now for a few different companies who've asked their support from us to, for some of these very specific scenarios to analyze the single points of failure and compromise. And then we, of course, did the public one, which uses Sparrow, Foundation Devices, Gordian, Seed Tool. I think that was the requirements for that. And in that one, Sparrow does not have any keys. So all the keys are not in the coordinator.
Yeah, this certainly grew out of that adversarial work. And here we were kind of looking at the adversary of time and effort, which are listed as adversaries in our original. So one of the interesting things about the sequence diagrams that I showed were that when I showed that really long list with all of the human actions and decisions and stuff, that was actually just getting one of the keys that Chris was pointing out. I think the one from Guardian Seed tool that is used for backup. And so the whole method is just so complex that help is needed. And I think that's true for a lot of work with digital assets.
Yeah. Often, so the other challenge is that we've got something called the NASCAR problem, and this has happened in other industries that has killed, interesting if not decentralization, at least distribution. So like OpenID at one point, allowed everybody to, in theory, have their own ID server. But there was also, this NASCAR problem where for a couple of years, there would just be this longer and longer and longer list of all the different services that you could offer. And to do your identity, and at the bottom would be you could do your own if you pasted this URL type thing. In the end, it was just too complex for users who don't like having more than one or two choices at a time. And seeing all these logos and stuff also meant that, the big guys had to be at the top, Facebook, Twitter. And of course, the big guys did not fully participate in the system. So they're at the top, but then they wouldn't support other people's open IDs. So it just ended up in this mess where the choices ended up being controlled by the people with the most money. And then the whole thing kind of disappeared. You sort of see it now a little bit with the federated login. Every once in a while, you have somebody say, you can log in with Google, or you can log in with Twitter, and you can log in with Facebook. And that's it. The sort of related to that, if we talk specifically about Sparrow, every time a new feature is being added, then you have to have some documentation that says, oh, well, in this app, in this wallet, you have to do X, Y, and Z. So there's this long little dialogue that says, go here, do tab this, go to this line, paste it here, or whatever. And every time he supports another hardware wallet, he's having to do that again. So now just this long lists of help that he's having to support, which means that, maybe he isn't spending as much time adding PayJoin V2 because he's just simply trying to support the fact that, Foundation Devices has upgraded their wallet, and now all those little choices are in different spots, and they're on different named screens. And with request response, you can just simply say, hey, wallet, this is the function I want you to do. When you're done, give it back to me. I don't care what you do, what you do, as long as you give me the response that I'm asking for. And then the wallet can basically go, yeah, I know how to do that, and lead the user through all the different steps. That help?
Yeah, where what's the tiny URL for the BCR? I missed it in the slides and I don't see it in the developer meeting markdown.
Sure. Can you paste that to the
Which URL are you looking for?
The BCR, it was like 2004-004. I have the multisig RR and the multisig documents, but not the one that I think is the request response itself.
Yeah, hold on. Let me grab it for you. And I will send it over in the chat. The tiny URL might have been BCR-2024-004, because that is the right number for the
and you can always ask these on the Signal channel. We have such a proliferation of different documents and examples and videos and other stuff of all of this type of things that we're always, puzzling out how to make it easier for people to be able to find things.
But I just sent it over in the chat too.
There it is. Yep.
So basically all of our research docs that we've been talking about are in GitHub. They're in a repo under Blockchain Commons called Research, and there's a master list of all of them that says what they all are, and also says what the status of each of them is. So BCR 2024-004 is the Guardian Transport Protocol Implementation Guide / the Envelope Request and Response Implementation Guide.
Excuse me. Great. Well, Dan, thank you very much for presenting today. And we'll be making this video available shortly, and hopefully you can also use it to try to get more people involved. And we would love to work with you to figure out how to, take it to the next step.
Well, let's do it. Thanks so much.
Thank you.
Thank you.
Thank you,
Okay,
Dan.
goodbye, everybody. Have a good week, and see you in the beginning of June for our next Gordian meeting. Thank you.
Bye, everybody.